Darhan Enven Kedi İş Geliştirme Müdürü Sayın Daniel Duggan'ı ağırlayacağız sahnede. Alkışlarınıza davet ediyorum kendisini.
Good afternoon. I'm here this afternoon to talk about the earthquake bracing reliability, getting safe and reliable seismic sway bracing actually installed in the buildings where the earthquake protection is required, and certainly buildings in Turkey require this kind of protection because it's not a matter of whether or not you'll have an earthquake, it's a matter of when the next one is going to be. The issue here that I'm going to discuss actually has to do with whether or not these braces that are actually installed are safe and reliable, and how can you tell that they're actually going to be safe and reliable. Now, I am a member of the NFPA 13 Committee on Hanging and Bracing, and a member of the ASCE 19 Committee for Structural Applications of Steel Cables and Buildings, and the UL 203A Standard Technical Panel for the listing, which writes the standard for the listing criteria, testing and listing criteria for earthquake braces. And I'm also on the committee for the ASTM A1023 cable, which is one of the primary steel cable that's used for cable-type earthquake bracing. I thought it would be helpful at this stage to also point out that in addition to those committee memberships, I have 48 years of experience designing all kinds of sprinkler systems. All of the special hazards included with that, foam water, deluge systems, supertex deluge, tank farms, all of it, cooling towers. And I have 30 years of experience in the design of earthquake bracing, and in addition to that, I have 8 patents, 6 of which are for earthquake brace components, and I've written technical manuals and articles about the issue. If we go to this next slide here, describes standards that I'm going to discuss, some of which will actually have application here, others will not, but it shows the relationship from one to the next. The International Building Code, which is primarily used in the United States, at least right now, makes direct reference, well, I should say the International Building Code and the FEMA standard that's the United States federal government, the California Building Code, the Unified Facilities Guide specifications, they all make reference to these standards that are listed below it. The NFPA 13 standard, which many people here would be familiar with, is directly referenced by the Building Code. And the NFPA, so it is a code compliant standard. The ASCE 7 document is the document that the International Building Code refers to for the earthquake protection requirements for non-structural building components. The ASCE 7 document also directly references NFPA 13, and both the ASCE 7 document and the NFPA 13, along with the International Building Code, directly reference ASCE 19 for structural applications of steel cables and buildings, and the cable assemblies that are used for earthquake bracing are structural assemblies. So all of these documents directly reference the ASCE 19 standard, and I'm on that committee. It's important to know that the ASCE 19 standard has a formal interpretation to make it clear that there are certain types of fittings that are known to damage the cable or loosen over time that are prohibited. And among those are what they call U-clips, cable clips, but they're U-shaped clips as shown on the detail on the left here, and wedge-type fittings. Now, these are devices that are quick connect fittings that have a wedge inside of them, usually with teeth on it that'll bite into the cable, that damages the cable and makes it loosen over, and can also loosen over time. The references to the standards, it starts out by, or I'm starting out here by showing what this actually means. The ASCE is the American Society of Civil Engineers. The SEI afterwards is the Structural Engineering Institute. The number that follows it is the number of the standard, so the primary standard is ASCE 7, and the -19 or -16 means it's the 2016 edition. So when you see the dash and the numbers after it, that means the year of the edition. These are the most current references. The ASCE 7 document is what contains the minimum design loads for buildings, and that includes all of them, including the earthquake forces, but also dead load, live load, snow load, and all of the other loading requirements. The seismic requirements for the non-structural building components are covered in Chapter 13 of ASCE 7. There is a section in Chapter 23 of ASC 7 that lists the standards that are referenced for compliance with these seismic requirements, and in that list of the seismic requirement standards is the ASCE 19 document. The ASCE 19, as shown here, is the ASCE SEI-19, or sorry, ASCE 19-16, is the 2016 edition. That's the current edition of the ASCE 19 standard. And in Appendix E, it has an appendix that is dedicated specifically to the cable assemblies that are made out of small diameter cable and used for the earthquake bracing of non-structural building components. The NFPA 13-19 is the 2019 edition, and that's the current edition of NFPA 13. And it is the seismic requirements are covered in Chapter 18. In the NFPA standard, there is specific reference to what is required to be done or what the components have to satisfy in order to be used in seismic brace installations. And under listing, it says sway bracing assemblies shall be listed. So that means it has to be an entity such as UL that is providing a product listing for these devices. You can't just simply make them up and think that it was a good idea for whatever it is that you're trying to do. The second paragraph here is saying that the components for the primary brace component that's shown in NFPA 13 in a table, pipe, rods, flats, angle iron, those particular portions, those elements, do not require an actual listing. But the fittings, this third paragraph says that the fittings that are associated with those components do have to be listed. This fourth paragraph is saying tension-only bracing systems shall be permitted for use where listed for this service and were installed in accordance with their listing limitations, including installation instructions. So it is requiring the tension-only bracing is the cable-type earthquake bracing, and it's requiring that it have a listing. It's also making it clear in this particular paragraph, although it is the case for everything, these products are listed for a particular application. That's the case with sprinkler heads or valves or anything else. They have a listing, and the fact that they have a listing doesn't mean you can just simply use them for anything that you want to. If you were to buy a toaster and the cord on the toaster had a UL listing on it, it doesn't mean that because that has a UL listing you could use it to hang sprinkler pipe. Included in the NFPA 13, in the annex, there's the specialty listing criteria for the cable assemblies that are used for earthquake bracing. And in the list of standards, and this is the list of the standards, the actual table that comes from NFPA 13, it shows that the manual for the structural application of steel cables in buildings, ASCE 19, is directly referenced by NFPA 13. So if you're doing all of this in accordance with the requirements of NFPA 13, you're already complying with that portion of it to use the ASCE 19. But that could be a debatable issue as to whether or not it's actually being complied with. In 2010, ASCE and the ASCE 19 committee voted on and passed a formal interpretation to make it abundantly clear that there are certain fittings that have been removed from the standard. They were only in there for one edition, but they've been removed from the standard. In order to have a formal interpretation, a question has to be asked that can be answered with either a yes or no answer. So this was done with two questions. The first one is a little bit more complicated, but it says, are cable clips and wedge type fittings not listed as acceptable for acceptable end fittings for use, primarily because they're normally intended for temporary construction activities and are subject to loosening over time and damaging the cable. So this is the reasoning behind it. And the answer is yes, they are not acceptable. It's a shorter question, for the second question was asked to make it even clearer. And the question is, are cable clips and wedge type end fittings unacceptable for use as fittings? And the answer is yes. So those two types of fittings are not acceptable to ASCE 19 or NFPA 13 or any of the other standards that reference the ASCE 19 document. Now these are a couple of examples of wedge type fittings. I didn't think it'd be necessary to put the U-shaped clips, a picture of that. The cutaway that's in the upper left-hand corner shows how wedges are used to actually bite into the cable to lock it into place, and the teeth on the wedges bites into the outer wires of the cable, and that's what damages. When they tested it, breaks early, and it breaks inside the fitting. In addition to this occurs at the time that the fitting is actually installed on the cable in the field. So some of the damage is going to depend on the strength of the guy that's actually doing the installation. In addition to that, after the installation is completed, these teeth stay in contact with the outer wires of the cable, and with the natural vibration that will take place in the building, they will continue to damage it further as time passes. So these are just simply some examples of what these things look like. So if the question is asked, do these wedge-type fittings satisfy the International Building Code, which is the IBC? The answer is no. Do they satisfy the ASC 7 document, which references the ASC 19? The answer is no. Do they satisfy the requirements of ASC 19? The answer is no. Do they satisfy the requirements of NFPA 13? The answer is no. And are they UL listed? The answer is no, because the UL listing is based on UL 203 test standard, which is based on the requirements of ASCE 19. And no products that have wedge-type fittings or the U-shaped clips are UL listed. Now, I'm showing here a few examples of some bad installations. Two of them are showing cable bracing. One of them will actually show strut, but I wanted to explain some of the reasons why. In this particular case, this uses the U-shaped clips, which are unacceptable. The brace itself is not connected to the sprinkler pipe. It even says in writing in NFPA 13 that the brace has to be attached directly to the pipe. This is bracing the hanger rod above the sprinkler pipe. And the hanger rod, because the force that comes from the earthquake occurs at the center of gravity of the component, the force here will come down below where the connection is made to resist it with the earthquake brace. And in the shaking motion back and forth, it'll bend that hanger rod back and forth and break it. It'll crack inside the threads and break. Now, in addition to that, you can see also in the picture that the hanger ring is not snug against the pipe, so it's lifting up on the pipe and it's in tension all the time. This is another example of a cable type brace that doesn't comply because it uses the wedge type fittings, which are unacceptable. The cable fittings themselves are not UL listed, and the pipe that's being braced would actually be able to slide through the ring or the clamp that's being used to attach the bracing to it. An additional item here is that because of the nature of it attaching to the ears of that clamp that are sticking out to the side, if the horizontal force came, it would be trying to pull that brace into a straight line going from the point of connection to the structure to the center of gravity of the pipe. And in doing that, it would tend to lift the pipe up and try to roll it over. In this case, this is an instance where the brace is actually using strut. There's strut type bracing that's used too, and also pipe type braces are the ones that are UL listed. And in this particular case, they put this together using a structure attachment fitting that's intended for use with strut, so it should be used at the structure, and it is hinged so that you can adjust the angle of the structure attachment fitting to accommodate any bolt direction and any brace angle. And instead it's used for the connection to the braced component down below. So if somehow there was a way to actually hold this still with that particular configuration, the fitting arrangement would easily bend because of the flat steel where the force would be applied. It would tend to bend. The fittings that are used in this are not UL listed, and because they use the structure attachment fitting to make the connection to the brace component, where that hinge pin is on that bracket, the pipe would just simply swing. So effectively, there is no brace on the pipe in this condition. Okay, in the ASC 19 document, the small diameter cable for the seismic sway braces is covered in Appendix E. So there's a separate appendix that's dedicated for this purpose. And small diameter cable is generally 3/8 of an inch and smaller in diameter. In this section, E 3.3.2 has to do with the actual strength of the fittings that are used with the cable. And this specifically states that the fittings and cable assemblies shall be developed the ultimate strength greater than the minimum breaking force prescribed by the reference standard. Now, the reference standard for the cable itself is going to be ASTM A1023 in most cases. What's being established here is that what is necessary is for the fittings and any of the connections that are used with the cable to develop or maintain the strength of the cable so that the cable is always the weakest link and you have one value that represents the overall strength of the cable assembly. It then reiterates some of this virtually the same information further down below in the type that's in red about maintaining the cable breaking strength, but it also says further during the test, the cable shall not break within the fittings. And that is what will happen with the U-shaped clips if they're installed properly or over-tightened or installed in the wrong direction, and also with the wedge-type fittings. And NFPA 13 itself has specialty listing criteria in it for the cable assemblies. Now, I wrote that specialty listing criteria in 1996 when it was originally proposed, and it's been this way ever since 1996, so it's not a brand new requirement. So NFPA 13 requires that the fittings that are used with the cable develop the strength of the cable itself, which means that you can't damage it with the fittings that are used with it. As far as the testing of the assemblies is concerned, because the ASC 19 standard is used for all structural applications of steel cables, includes much larger cables too, and there are requirements for testing these assemblies before they're actually installed. So there is this same requirement that's in the Appendix E that's for the seismic bracing, but it says that listing and labeling by a nationally recognized third-party organization not directly affiliated with the manufacturer is an acceptable form of testing. So in lieu of testing in the field, you can rely on the listing that would come from an entity like UL. In addition to that, there is a requirement for color coding, a continuous color coding of the cable. It's not for decoration, and it's not for just product marking so that you can identify who made the product or anything like that. It's for a specific purpose to make it possible for an inspector to inspect to see that the proper cable has actually been installed according to the strength requirements and what was detailed on the drawings. The color coding will end up being it's not a coating, meaning just covering the outside of the pipe. It's a code, and the code for the color tells the inspector the diameter of the cable. These are small diameter cables. They could be 3/32 of an inch in diameter, 1/8 of an inch in diameter. From the ground here up to the level of the ceiling, an inspector would not be able to tell the difference between those two sizes of cable. The strength of the individual cables will vary according to the number of wires that are in the cable. There's what's called 7x7 construction and 7x19 construction. Those are very common ones and most commonly used for the bracing. The 7x7 means there are 7 wires twisted into a cable, and 7 of those cables are twisted into the finished cable. So there are 49 wires. If you have 7x19 cable, there are 133 wires. Depending on that construction, the load, the ultimate strength of the cable will actually change, and therefore so will the load carrying capabilities of it. So this color coding is identifying that it is the UL listed product, who the manufacturer actually is, because we have our own colors for it, what the diameter of the cable is, what the construction is for the number of wires that are actually in it, and what the strength is according to the standard. So it's communicating all of that to the inspector that should be looking at these things in the field. In addition to that, there are 2 other paragraphs, 8.1 and 8.2, that specifically prohibit doing anything with the cable at the time of installation that would damage the cable. As far as listing concerned, the listing was done by entities such as Underwriters Laboratories. UL has the testing and listing criteria in UL 203A. That is the listing criteria for both the rigid pipe bracing, rigid type bracing, primarily pipe are the ones that are listed for the primary brace element, and the cable type bracing, both of them. And the requirements in the UL 203A comply with the ASC 19 requirements. Okay, now some of the issues that are involved in this is that sometimes the sway brace suppliers will make false claims of having a UL listing and compliance with ASC 7 or ASC 19 or NFPA 13 just by putting it in their literature. And it's very easy for people that are purchasing these components to rely on the literature that they get from the manufacturer. That's done generally with sprinkler heads or valves or anything else. But what you're actually supposed to do when you're looking at products that are listed, at least at some point, is to verify that there actually is a listing. I'm saying for the products that I deal with, you should verify that what I'm telling you about us having the listing, you should actually look at that. In fact, for that matter, you people have never met me before. I'm up here claiming that I'm a member of the NFPA 13 Committee on Hanging and Bracing. I would invite you to actually look in NFPA 13 for the roster of the Hanging and Bracing Committee and see that my name is there. Same thing with these other standards. So there's nothing wrong with actually checking on this, and it's really a good idea to do it in this particular circumstance because there are quite a few false claims that are being made. Some of the documents that are actually used to try to convince people of this may even use the UL logo on it when they're not actually being allowed to or haven't gotten permission to, so you can't necessarily actually rely on that. The listing and testing is based on the UL 203A criteria. There is no other, throughout UL, there is no other seismic brace listing criteria other than the UL 203A, so it has to have come from that. Because you can't rely specifically just on the literature, you need to go to UL and the UL directory at least once and check that what you're being told about there actually being a UL listing actually exists. Now, this is an instruction, and you can do it while I'm talking if you actually wanted to. This is an instruction of how you actually go to UL and check for the listing. It's not very complicated. You go to ul.com, you scroll all the way down to the bottom of the page, you click on UL Product IQ, that's their new name for this, certification search, and when you click on that link, you will go to a page where it will ask you to create an account, which is really nothing more than your name and your email address, so it's free and it doesn't take any time. That then allows you into where you see the search box, and when you do the search, UL has two product codes for seismic bracing. The one for rigid bracing is VGMY, and the one for cable type bracing is VGMI. So if you just enter whichever one you're interested in finding out, and you should do it with either one, because you can't necessarily rely on the literature about the rigid bracing either. For instance, there is no strut type earthquake bracing, which is the rigid type bracing that is UL listed. So getting back to the cable type, if you do the search for the VGMI, that will then show you the suppliers that actually have a UL listing for their cable type earthquake bracing. And what I'm saying here at the bottom is that there are only two suppliers that have a UL listing for the cable type bracing, and the results might actually surprise you if you've had any dealings with this. This is actually a screenshot of what you would see in the UL listing, and there are two up there. One of them is Erico International Corporation. Now on the actual listing page, when you go to that, you'll see the trademarks that are down below here, and that's where you see this is ours. This is where you see the Invent Caddy, the Caddy Man, all those trademark symbols. But this is how you would know, for instance, that we have an actual UL listing for the cable type bracing. And you would also be able to see from this list that people that you may have been told have a UL listing do in fact not have a UL listing. And I would say as far as the conclusions for this, it would be a good idea to confirm the existence of the product listing with the listing entity, whoever it is, such as UL. Don't just take the supplier's word for having the listing. And that's even if he shows you documents that would have like a UL label on it. And I would also suggest that if a supplier misrepresents having a UL listing and you find that he does not, it's probably not a good idea to rely on what the rest of the information is that that supplier provides to you. And the final thing that I would say is that in the ASC 19 document, there are two types of fittings that, as it stands right now, that are actually provided for in ASC 19 that comply. One of them is a poured socket, and a poured socket is a type of fitting that you use molten metal in a cone shape that you put the cable up through and splay the wires out, fan the wires out, and pour the molten metal into it. And that's a poured socket. And the other one is a swaged fitting, where you actually use a tool where it'll move the metal and swage the attachment device permanently to the cable so it can't be moved.